Okay, welcome to another how to create or measure a chassis and create a model in RC Crew Chief. So the last one I did was for an off-road, and so this time I figured it would be appropriate to do an on-road. So I've got a TC 7.1 here that's in the process of being built. This is by far the best time to measure up your chassis, because this way at least you know that everything's square, there's no tweak in the chassis, everything's perfect, and that's exactly the way you want it, because you don't want something that's got a bent chassis or hinge pin or whatever. Anyways, I've already prepared some of the sub-assemblies. I've already built the shocks. The new version of RC Crew Chief does do shock modeling. So you can take measurements for your shocks. Hopefully you can read this, but I've already done it. You just have to go on to the chassis manager and open up the shock tab, and there's a measurement sheet there that you can print out. That's exactly this. So it shows you all the measurements that you need to need to take to create a shock model in RC Crew Chief. So I'm not going to say any more than that. It's pretty straightforward and easy to do. So what we're going to focus on now is taking measurements for suspension and steering components. So what I have here is just the chassis, and I've just installed the suspension mounts, inserts, and hinge pins. So first thing you want to do is just take a couple of basic measurements off the chassis thickness. In this case it's 2.3 millimeters, and the chassis width, which in this case is 87.1. Then we want to start getting into the actual suspension mounts. So we're going to measure the X1 and the Y1, which is the X1 is the distance from the center of the chassis to the center of the hinge pin, and the Y1, which is the distance from the underside of the chassis to the center of the hinge pin. So these are relatively straightforward to measure. You just need your trusty digital calipers. So for the we'll do the X1 first. So the X1 dimension, we just measure outside to outside of the pins, and I usually measure it in a couple different places, and then we subtract off the hinge pin itself. So the actual calculation is outside to outside of the pins I determined was 46 millimeters. The diameter of the hinge pin is 3 millimeters, so we have to take off half of the diameter on one side and half of the other, or full diameter. So it's 46 minus 3 millimeters for the hinge pins, and then we divide that by 2 because we want the dimension to the center line of the chassis. Now the Y1 dimension is done very similarly. We just measure from the bottom of the chassis up, and that then is that measurement, the bottom of the chassis to the top of the hinge pin, minus 1/2 of the hinge pin. So that's it. The rear is a little different because we obviously have an angle on the hinge pins, so we need to measure at the rearmost position, measure that dimension, and then measure the frontmost dimension, this dimension, and take the average of those two measurements. So we'll go to the rear. So on the rear here, so you can see here I've got the widest is 47.32, narrowest is 44.18. Sum those, divide them by 2, that gives me the average. Again, subtract off the hinge pin diameter and divide the whole thing by 2. The Y1 is exactly the same measurement as the front. Now, something to point out here. When you're doing this, you want to take note of where the hinge pins are placed. In this case, on the rear, the hinge pins, or the inserts in the suspension blocks, are 1 dot and 1 dot, and we also have a 0.5 millimeter shim underneath the suspension blocks. So you want to take note of that, because when we get to creating the model, we need to use this information as a reference point to create other positions for location of that hinge pin, because it can move outward, inward, up, down, and we need to make sure that we're referencing it to the correct place. So very important that you do that. And I also did that on the front suspension as well. It was -3, and it had a 0.5 millimeter shim underneath it as well. Now the other thing you want to do at this stage is record the actual suspension blocks inserts and determine where they are. So on the Associated they have a 1 dot, a 2 dot, and a 3 dot, and I've measured those, and the 1 dot is with the hole exactly in the center. The 2 dot, it's 0.5 millimeter off center, and the 3 dot, it's 1 millimeter off center. So again, very important because we'll use that later to enter in alternate positions for the suspension blocks. So that's it for this guy. So now we're going to do some measurements on, we'll do the steering hub first. So we need to create a model for the steering as well. So I'm just going to move over to the steering rack worksheet. So again, you print out the sheet from the steering tab in the chassis manager, and it gives you all the measurements you need to make for, this is for a dual bell crank version. So what we're going to do here is we're going to do the hub. We're just going to measure this XSA and YSA, which is essentially the offset of the pivot point for the tie rod connection from the pivot point of the steering. So that is a fairly easy measurement to make. So first we're going to do the X1 measurement. So what I do is I just take the steering knuckle, place it flat onto a nice flat surface. I see I've already got the ball stud mounted, and then I just take my calipers and I just measure from here down, record that number, which is 22.6, and then the other number I need is, because I want to measure from this pivot point to this pivot point, so I need to determine where that is. So I need to take this measurement as well. So we'll do the same thing, take that measurement. So what I end up with is 22.6, which was the measurement to the ball stud. Subtract off half the diameter of the ball stud, and then subtract from that the height from here to there, which was 17.8 millimeters. And then to get to the center of this, I need to add back on half of the diameter of this mounting boss here. So if you do all that, you end up with 6.35 millimeters. Now because we have two mounting places here for this steering knuckle, I need to measure and determine where the other position is as well. So simply just move your ball stud to the other hole. If you got 3 holes, you got to do it 3 times, and just do the same measurement again from here down, and what you'll end up with is just the difference in the two numbers. So in this case it's 26.6 minus 22.6, so it's 4 millimeters is the difference between the position there and the position there in the X direction, so along the axle center line. So now we got to determine the other direction. We need to know what the distance is from here to here. So again, this one takes a little bit more fiddling around because you want to try and make sure it's perfectly in line with the axle line. Excuse me. You can also do it from here. There's another way to do it, but I usually just do it from the outside of this boss, and that's the way I did it in this case. So I'm just going to repeat that. So I just measure that distance there, and then subtract off half of the pivot or the ball stud and half of the mounting boss. So, and there's what I've got there is 35 millimeters minus 4.3, which is the pivot ball diameter or the ball stud diameter, and minus 7.4, which is the diameter of this mounting boss up here. And again, we have to repeat that for the ball stud in the other location, and here I've done that calculation as well, and it's 35 minus 33, so it's 2 millimeters. So we got a 4 millimeter offset and a 2 millimeter offset. And again, we'll need that when we enter the model because we can look at different positions and see what kind of effect that has on Ackerman. Okay, so now we need to do some other things with these components. We need to determine our kingpin length and our axle length. So the kingpin length for the front can be a little tricky because we usually have caster built into it. So what I do is I measure from the upper side to the top of the pivot ball or ball stud, and then I measure from the lower side, same idea, and then I take the average of those two measurements, because really what we're looking for is we want the distance at the midpoint, because this is the kingpin length is from here to the center of that ball stud. So I've done that here. So I've got 37.57 on the upper side, 38.74 on the lower side, and divide that by 2. Subtract off half of the hinge pin diameter, which is 2 millimeters, and then we've got this tricky little guy here, which is where exactly is the center of that ball stud. Now you could just say it's 4.3 millimeters divided by 2. That would be close but not accurate because we have a flat on the top of the ball stud. So we can use a little math and figure out what that is. And this little sketch, hold it up so you can see it, shows our ball stud. So what you need to measure, in our case here, we only really need 2 measurements, which is the diameter of the ball stud, which you already know is 4.3 millimeters, and the diameter of the flat that's on top of the ball stud, which I've measured as close as I can get, and it's 3 millimeters. If you were doing a pivot ball or something like that, you would need this height dimension as well, but we don't really need it here. I recorded it just for the heck of it. So all we need to know is what is the distance from the top of that flat to the center of the ball stud. So here's the calculation here. So it's the larger diameter squared minus the smaller diameter squared. Take the square root of that and divide it by 2. So that number comes out to be 1.54 millimeters. So if we go back to the other page, that's where that 1.54 millimeters comes from. So do all that, and that gets you what your kingpin length is. Now another important thing here, you'll see I've added plus 1 millimeter shim. So this measurement was taken with a 1 millimeter shim underneath the ball stud. Again, when we go to enter the model, you'll see why I've done that. Okay, the other one we need to do is the L axle, which is a distance from the center of the axle to the lower pivot point. So again, we do something fairly similar. What I usually do is measure from here. Well, actually we can do it this way. This way is actually easier. This is actually what I ended up doing. Is I just measured from the outside to the bottom of this boss here. Measured that dimension. Measured the diameter of that. Measured the total height of this to the bottom of the boss, and then the total height of that. So you take 4 measurements in this case to come up with that number. So we've got 26.4 was the overall measurement. Diameter of the steering hub where the bearings mount is 14.2, and then we have to take off how far this boss sticks up above the main hinge pin section. So that is the 9.05 minus 7.32, which is the thickness of that, and then we have to take off half of that 7.32 divided by 2. So that gives us our 1391 number. So sometimes you got to be a little creative and just think about where you want to get to and how you got to go about getting there. So that's the front, and we have to do the similar thing for the rear. So the rear, I've got one pre-assembled here. Here it is. So this one's even easier to do because we don't have to do any messing around because of the hinge pin, because there is no caster built into the hinge pin. So all we have to do is measure this dimension and then take off half of this dimension and our ball stud. So that's what I've got there. I got 40.9 minus 6.8 divided by 2, which is the diameter of this bottom boss here, and minus the 1.54, which is the distance from the top of the ball stud down to the center of the ball stud.